Module 11 is probability distributions, and I want to get you to understand what normal probability is. Well, before we get that, it's important to look at the binomial distribution or binomial probability. Take a very simple case. Take something where we're flipping a coin and the chance of getting ahead is 0.50, right? There's a 50-50 chance. Now, what if I asked the question is, how many ways can you get heads or tails if you're flipping a coin twice? On the first flip, you could get a head and a head, and a head and a tail and a head, a tail and a tail. If it's a half times each, a half times a half, or 0.5 times 0.5 is 0.25. So the chance of getting a head on the first and a head on the second is 0.25. Getting a head and a tail is 0.25. Getting a tail and a head is 0.25. Getting a tail and a tail is 0.25. However, if we look at it in terms of, you notice that how many heads do we have? On the first one, you got 2 heads. On the second one, you got 1. On the third one, you got 1. And then on the fourth one, you got none. So you got 2 chances out of 4 of getting 1 head. If we put that into a table, in terms of the heads, having 0 heads, you've got a 0.25% chance. Or if we made a bar chart, it would look something like this. For 1 head, it would be up here to 0.50. For 2 heads, it would be 0.25. And I could look at it and say, this would be a binomial distribution with a probability of 0.50, and I would be doing it twice. Okay? Now, to make this look nicer, let's see, zoom it properly. I want to set the scale right. This is what it would look like on a nice chart. If I flip the coin twice, okay? They're looking at it in terms of, here they're counting 1, 2, and 3. I had it as 0, 1, and 2. But you notice it's 0.25, 0.50, 0.25. The important thing is, if I increase the number from 2 to 5, what happens to this distribution? Okay? It doesn't climb directly. It looks like this. So that the chance of getting the first one is what? About 0.25. Then it goes up to 0.025, and then 0.16 or something, and then 0.31. Okay? But do you notice this is symmetric? This would be flipping a coin 5 times. So I could get, really I would go from 0 to 5 if I was doing that. In this case, they've got it listed as 1 to 6. I picked this out of the book. So the charts would look nice. But what happens if I change this to doing it 10 times? Keep it on the same zoom. Okay. There. Do you notice that the center is picking up the bulk of the items? And then if I did it where n was 20, so if I flipped a coin 20 times, what would I have? It would start looking like this. Okay? Do you notice that that is almost the normal distribution? In other words, if I took the binomial distribution with a probability of 0.50 and increased the number of times that, say I flipped a coin, if I increased the number of times I flipped the coin, this is for 20. If I put it over 100, if I did 1,000, it would look just like the normal distribution. Okay? And so this is where I'm saying is the normal distribution is not something that somebody dreamed up a formula and said this is how it has to be. It's that they noticed this in nature, and the results As a matter of fact, it was a guy by the name of Carl Friedrich Gauss who noticed and said, oh, that's one of these. And he came up with the formula. And all of statistics was built that way. They look at how do things behave, and then they think about it, and they try to come up with mathematical formulas that approximate what you see going on in nature. Now, with that, I want to get an idea of skewness. What do we mean by skewness? Let's take the same type of thing where n is 2, and the probability of success is 0.10. Instead of 50-50, let's say I was flipping a coin, but the coin is loaded so bad that there's only a 10% chance that it comes up heads or tails. Then my distribution is going to look something like this. For 2, when I increase that to 5, I'm going to get something that looks like this. And when I increase that to 10, just to show you what's happening here. And then I can increase that to 20 occurrences. Okay? This is what they would call skewed. Okay? And you notice the tail runs off to the right. This is skewed to the right. Let's look at the same type of thing with probability of 0.30. Here's when n is 2. Here's what happens when n is 5. Okay. Here's what happens when n is 10. And when n is 20. Okay? You see that it slid the distribution. The bulk of the distribution is over to the left, but it tails off slowly to the right. Okay? This would be said to be skewed to the right. What does that mean? Okay? Skewness is not something weird. It is something that deals with regular occurrences when there is a bias to one side or the other. In other words, the normal table comes about from something where there is no bias, so it's a 50-50 choice, and you do it thousands of times. If there is a bias to one side or the other, then you are going to get a skewed distribution. So by looking at how the outcome of the occurrence you're looking at lays out, it will tell you whether there is a bias to one action or the other. What do I mean by that? If you took a large pine tree and you looked at the pine cones falling in a pattern around it, they would be clustered. If there was no wind and nothing biasing one way or the other, they would probably be in a nice pattern close to the tree, but the further away from your tree, you would have less and less pine cones. Now, if you put a bias into there, like a prevailing wind from one direction to the other, if you looked at the resulting pattern of the pine cones on the ground, you would see a skewness in one direction. In other words, the bulk of it would be going with the wind, but you'd still have a few to the other side. Okay? This is really important that when we talk about this, and outliers are just things that something happened, something unusual happened so that you get an unusual result. It doesn't mean anything bad. Looking at it, the other point that I would like to make is, let's go back and I'll just put up the normal table, is when we're talking about this as to where Okay, if using this as a precursor, this was my 50-50 table with 20, like flipping a coin 20 times. It's really important for you to think about, because the word normal has been grossly misused in our literature and our talk, and our vocabulary. When we talk about normal, we usually misinterpret it. Remember, within normal, that on a normally distributed population, roughly 2/3 of the population is within 1 standard deviation of the mean. And roughly 95% of the population is within 2 standard deviations, and 99.74% is within 3 standard deviations. What does that mean in English? Let me give you an example on something. I just want to pick the thing up. Let me draw a picture here. Okay, let's go with our IQ test thing. 115, 130, 145, 85, 70, 55. We're centered about here. We go 1 standard deviation. Hope you like my artwork. Okay, this is 1 standard deviation. In either direction. I've got 68% of the population. If I go 2 standard deviations, I got 95%. If I go from here to here, I get 99.74% for 3 standard deviation. Okay? Now, what does that mean in English? If I take 10,000 people, (9,974) of them, or 26, are going to be outside of this. Or you got 13 up here and 13 down here. Let me pull this in a little bit. Okay? What does that mean? Let's put this in context. If I take 10,000 people at random, and if this is true, you give them all IQ tests, something. Okay. Between 85 and 115 is what we call average. 115 to 130 is the above average. 70 to 85 is the below average. Those are the slow learners and the fast learners. Below 70, they refer to those people as retarded. Now, they don't like, you can't use that label anymore or something, but what it's saying is that those people have trouble learning in a reading and writing type setting. It says nothing about what they can learn or can't learn. On the flip side, the 130 to 140, those are your real quick learners. Those are the ones that are sharp. In school, they're great. Why? Because they can learn despite the teachers. You just point them, get out of their way. That's your gifted and talented and stuff. Now, out of that 10,000 people, you got 13 on either end. In other words, that 145, when you get above there, they call you a genius. And the 55 down on the lower end, if you score down there, they say that you can't really learn. They teach you survival skills and stuff that you cannot learn in a reading and writing type environment. The 145 up, you're considered genius. Okay, now, what does normal mean? It doesn't mean that you're between 85 and 115 or between 70 and 130. Okay, most people take that, okay, normal means that you fall within that. No. Normal means that for any attribute that you have that is given without prejudice, that comes to you genetically, or that they're going to be distributed like this. That 13 people out of 10,000 will have IQs of genius. just like 13 will have real low IQs. That is normal. The fact that you happen to have one attribute and you're on that end of the scale, that doesn't mean that you got those attributes are given out randomly. You don't have the same things. Like, I could score very high on an IQ test. Wow, that makes me a genius. On the other hand, if you came down and measured physical dexterity, I might be the biggest klutz in the world. You know, I take myself, for example. I score very high on certain types of these tests, but when it comes to performance things like music or something, in terms of music, I'm retarded. These things tend to balance out, and we've got to. And what is normal is that you're going to have a distribution of it. Think in terms of sports skills. When you were a kid, most of the kids playing baseball or something when you were a kid would score in the middle range, and you'd expect that you had some kids that were good and others that were not so good, but everybody could play. You had a few that were really gifted athletes and, you know, were better than everybody else, and wow, you know. And you didn't have them necessarily in every neighborhood, but, you know, as you got together, when you were playing in a little league and they started putting bigger populations together, guess what? You ran across a few real gifted ones. You didn't run across the real klutzes because they hated going to gym class or doing it. Why? Because they had no athletic ability. Now, the term normal refers to this distribution. It is perfectly normal that this happen. It is not normal that everybody be in the middle and that everybody have 100 IQ. It is normal that the population is divided up, that most people fall in the middle, but it is just the luck of the draw that someone scores real high or real low. That's what happens naturally. And the normal distribution refers to the fact that this is what's happened across the board. Anyway, that's it for now.